Problem is problem 3 of the MIT integration B qualifying exam 2012. That is indefinite integral of 1 over 1 plus the square root of x, close bracket, times the square root of x minus x squared. So let's jump quickly into it and see how we could solve this. So our problem as we introduced it is the indefinite integral of 1 over 1 plus the square root of x times the square root of x minus x squared. And how I would feel inclined to rearrange things is I would keep this part as it is and then pull that part out and be left with 1 minus x under the square root, the second square root sign. Then the next thing is we want to substitute this ugly part off, and I would just say let u be equal to the square root of x such that u squared is equals to x, and then the derivative 2u du dx equals to 1. Therefore we can substitute for dx with 2u du. Very important part here. So our integral now becomes 2u du in place of dx over, in place of square root of x, we have u square root of 1 minus u squared, where this x here is u squared. And that would cancel, so we have 2 du 1 plus u times the square root of. So we've gotten there, right? Let's continue. Our problem now is 2 1 plus u square root of 1 minus u squared. And focusing on this part, we have 1 plus u square root of 1 plus u 1 minus u, right? So I could do something, bunch this part and this part, and we have 1 plus u 3 over 2 to the power 3 over 2, 1 minus u the power half. The next thing is I may want to substitute this another ugly part off. So just say let y be equal to 1 minus u to the power half such that y squared is equal to 1 minus u, and so 2y dy du is equal to negative 1. And so what that means is that 2y dy is equals to that. And we could just say in place of du, we can substitute with negative 2y dy. Which is good because our previous integral was 2 du 1 plus u 3 over 2 1 minus u a half. So this part is going to be y, but then if y squared is equals to 1 minus u, and so u is equals to 1 minus y squared, therefore u plus 1 is equals to 2 minus y squared. So we're going to use this in place of this. And so we're going to have now our integral of 2 in place of du. We have 2y dy negative over, and we have another y here in place of that, so that and that cancels, and in place of 1 plus u to the power 3, we have 2 minus y squared 3 over to the power 3 over 2. Okay. Let's keep going. So we now do have negative 4 dy 2 minus y squared 3 over 2. So this is an interesting step, because now what I could do is I could say let y be equal to square root of 2 sine theta, such that dy d theta is equals to root 2 cosine theta, and we can substitute for dy with square root of 2 cosine theta d theta. Right? An important phase here. So our problem now becomes negative 4. In place of dy, we have root 2 cosine theta d theta. And here we have 2 minus 2 sine squared theta to the power that. Okay. So we can pull 2 out. Negative 4 root 2 cos theta d theta, and then we have 2 out cos squared theta to the power that. Okay. And let's continue. So our problem now is negative 4 integral of root 2 cos theta over 2 to the power 3 over 2 cos squared theta over 3 over 2, which is just cos cube theta. And so this is same as 2 cos theta. This is 2 over 2 square root of 2. So this one and this one cancel, so we have negative 4 over 2, and we have 1 over cos squared theta. So which is now negative 2, the integral of sec squared theta, which is negative 2 tangent theta plus integration constant. So this is a partial problem. So let's continue making that simple. Since our partial answer is negative 2 tangent theta plus c, and also since we said y equals to root 2 sine theta, such that y over root 2 is equal to sine theta, that means if we have a triangle, a right angle triangle, and the angle here is theta, and sine theta is opposite over hypotenuse, our opposite would be y, and hypotenuse would be root 2, such that our base is, or the adjacent is root 2 squared, which is 2 minus the opposite squared, which is y squared. So tangent theta, what we're trying to look here, is the same as y over square root of 2 minus y squared. And so right now this would be equal to 2 in bracket y over square root of 2 minus y squared plus c, right? So this is just by the way. And now we also have to step back and express this in form of u. And that's what we're going to do in the next slide. So since our partial answer was 2y over square root of 2 minus y squared plus c, and initially we had also said that let y be equal to 1 minus u square root. That means that in terms of u, we would have 2 1 minus u over the square root of y squared is definitely 1 minus u, which is equals to negative 1 minus u over square root of 1 plus u, because it becomes 1 and then plus c. And then this is also partial because we have to take it back to the x domain. I think that would be our last point. So our partial answer being 1 minus u to the power half over square root of 1 plus u plus c, and initially we had said that u be equal to the square root of x. That means that our integral is 2 1 minus square root of x the power half square root of 1 plus x plus c. And just, we could simplify this a little bit further by expressing it in a way that allows us to simplify it a little bit further. And that means that we could also express it as one big, and so we have one simple expression could multiply the numerator by since this just divide, this is equivalent to 1, but we're just trying to simplify things a little bit. In the numerator we get 1 minus square root of x or square root of 1 minus square root of x squared, which is 1 minus x plus c. And we can, because we have a sign here, just to remove this negative outside, we can do some other things. Let's just simplify it. This is what we had: 1 minus square root of x over square root of 1 minus x plus c, and that means that our big integral that we started with is the same as 2 square root of x minus 1 over 1 minus x plus c. And this is our final answer. It's been a little bit winded, but I think it's a very interesting problem. So, well, until next time, be blessed, and yeah, it's been an absolute pleasure.